Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebohang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we'll be focusing on mechanics, which has a total of 93 marks. And under mechanics, we'll be focusing on Newton's second law, which is mainly your question 2, which has plus minus 21 marks. So just to remind you, on the mark allocation regarding paper 1, we have two sections. We have your section A, which consists of 10 multiple choice questions and has a total of 20 marks. And then we also have either 8 matching items or 8 one-word items, which has a total of 8 marks. And then again, we have your section B, which consists of structured or long questions and has a total of 122 marks. So now for paper 1, the total marks are then 150 marks, and the duration for the paper is then 3 hours. Okay, so just to remind you, so far we are busy with the chapter Newton's law of motion, and so far we have covered Newton's first law, and under Newton's first law we have then covered your inertia and mass, and then we have also covered your Newton's second law, which consists of the formula F net is equals to ma. And under Newton's second law, again, we did your free body and force diagrams, and we also talked about the acceleration. So we have not covered your Newton's third law as yet. And then under Newton's second law again, we talked about the normal forces and the different scenarios that we have in terms of the normal forces. So you can have a horizontal surface. So if you are to represent the normal force on a horizontal surface, then this is how it would look. So you would have to draw your normal force from where? From the surface, and that is how you indicate it. And then from there you would represent your gravitational force. And then let's just say that for as an example, you maybe had an applied force to the right hand side, an applied force to the right hand side. So your applied force would be your your Fa. So how would you represent that? Using a free body diagram. You would then have to represent your object using using a dot, and then you'd have to represent your normal force going up. Your gravitational force would then be going down, and then your applied force would then be indicated going in which direction? To the right hand side. So remember, when you draw your arrows, remember that all your arrows, they need to touch what? In terms of the free body diagram, all the arrows need to touch the dot, and then all the arrows need to point away from the dot. So what would be your formula then in terms of the normal force if you just have a horizontal surface? The formula would then be Fn is equals to what? Fg. So from there, what do? You can then break down the Fg into what? Into your mg. So where you know that your m, it represents your what? It represents your mass in kilograms, and then the g represents the gravitational acceleration constant, which is then what? 9.8 meters per second squared. So from there, so we just talked about what? A horizontal surface. So from there we can also have what? A pulling force and also a pushing force. So for a pulling force, you would then represent your object using a box, and then from there going upwards, then you would represent your normal force, and then going downwards would represent your gravitational force. And then they now told you that it's a what? It's a pulling force. So you would then draw your applied force where maybe let's say again it is to the right. So how would you represent a free body diagram now in this case? So with the free body diagram, remember then you are going to use what? You are going to use a dot, and then going up you have your what? Going up you have your Fn, and then going down you have your gravitational force, and then to the right you have your applied force. So remember you have an option of using this free body diagram, or you also have an option of using another diagram. So in this case, let me just show it to you. So it would be the normal force going up, and then the gravitational force going down. So this one would consist of your components. And when would you be using these components? You would use these components whenever you need to do whatever calculations. So we have what? You need to draw the components of the applied force. So what components do you have? To the right hand side, you will have what? You will have Fx, and then because this force was pulled where upwards in a way, then it means that you will also have your Fy there going upwards. So when you are in the examination, you have an option of drawing this one or drawing this one, but this one, remember I said that you are going to need to use it especially when you have to do your calculations. So what then is the formula? How would you then represent the formula of the normal force if you have a pulling force? So it would be Fn is equals to what? Fg minus what? Minus Fy. So it means that your Fy in this case, it represents your what? Your component. So you would then have to break down the formula, which is then what? Mg minus what? F sine theta. So from there, the mass again is what? I mean the M again is the mass in kilograms. The G is your gravitational acceleration constant, which is 9.8 meters per second squared. And then the F, this F would be whatever force that you were given here as your applied force, and then sine theta would then be whatever angle that you were given there. Then the last one then would be a scenario where you are given what? A pushing force. So again, with the pushing force, if you are to represent your object using a box, meaning a force diagram, then going upwards would be your what? Would be your normal force. And then from the center there, you'll have your what? Your gravitational force. And then let's just say that now it is a pushing force, so pushing downwards. Then how would you represent the free body diagram? So for the free body diagram, again, you would have your normal force going up, your gravitational force going down, and then applied force in which direction? Applied force going down, so downwards. And then again, you can represent it using the components so that you are also able to do your what? Your calculations. So from there, you'd have your normal force going up, you'd have your gravitational force going down. So because this force was pushed
Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
welcome back, learners. So if you have any questions, we have a WhatsApp number. Remember to send your questions to the following number: 063 508 1301. I will repeat the WhatsApp number for you. It's 063 508 1301. Okay, so we were still discussing the pushing force, and we said that if you have a pushing force, so this arrow here, this applied force here, it represents what? It represents our pushing force. So in this case, the applied force is where is downwards. Hence, that's why on the left hand side we are going to have your what? We are going to have your Fx, and then going down again, we are also going to have our what? Our Fy. Okay. And then how would we then calculate the formula of the pushing force? How would we calculate in terms of a pushing force? So our formula will then be Fn is equals to Fg plus by what? Plus by Fy. So our Fg, when we break it down, it will then become what? Our Mg plus by what? F sine what? Theta. So again, this one we are saying it represents a pushing force. This one, it represents what? A pulling force. So the difference is that on this one we need to subtract our Fy, and on this one we need to add the Fy. Okay, so again, the M represents the mass in kilograms, and then the G represents the gravitational acceleration constant, which is 9.8 meters per second squared, and then the F will represent whatever force that we would be given there as the applied force, and then this one, the theta, will represent whatever force that, whatever angle that was given there with our force. Okay, just to remind you again on Newton's second law definition, we said that when a net force, so F net, is applied to an object of mass m, so again according to the data sheet, when a net force, okay, is applied to an object of mass m, the object will do what? It will accelerate in the direction of the net force, and then we said the acceleration A is therefore directly proportional to the net force and inversely proportional to the mass. So remember, with definitions we said that it's either you are going to get what? It's either you're going to get 2 marks or 0. So you need to give the full definition. You are not just going to define and then leave it by the net force. You need to give your definition all the way up until what? Up until the mass. So again, just to remind you on this one, we said that the acceleration is directly proportional to the net force. So we said, what does that mean? It means that as you apply, so the more net force that you are going to apply, then the more what? Acceleration. So as you increase the F net, as you increase the F net, the acceleration will also do what? The acceleration will also increase. Okay, and then we are also saying that so the acceleration A is directly proportional to the net force and inversely proportional to the what? To the mass. So acceleration is directly proportional to the net force, but the very same acceleration is inversely proportional to the what? To the mass of the object. Okay, so components or resolution of forces. So this one, they would normally ask you to calculate the horizontal component, or for you to calculate the vertical component. So let's just say, for example, on this one, you are given a force of maybe 230 Newton. And then as an example again, let's say that for the angle you are given what? Let's just say you are given 30 degrees, and then you are then asked to calculate maybe the horizontal or the vertical component. What is it that you are going to do? So we can use our soccer tour. And then we said that with this one, the S it represents sine theta, which means what? Sine theta is equals to the opposite over the hypotenuse. And then the C would represent what? Cos theta is equals to the adjacent over the hypotenuse. And then the tan theta is then your opposite over the adjacent. Okay, so from here, what are we going to do? This side we have what? We have Fy on the left hand side, which is then also equal to the Fy on the right hand side, and then at the bottom we have what? We have Fx, which is also equal to the Fx there at the top. Okay, so let's just firstly use sine and see what we can calculate from there. So using sine theta is equals to what? Sine theta is equals to our opposite in this case. In terms of this angle, our opposite is represented by what? By Fy, and then our hypotenuse in this case is what? Is represented by this applied force. So we can then say this one is the applied force. So we said that if you are given an angle of what? Of 30 degrees, what is it that you are going to do? You will then say sine of 30 degrees is equals to Fy over what? Over 230 Newton. So from there you are then able to calculate your what? Your Fy. So it would then be Fy is equals to 230 sine of what? Sine of 30 degrees. Okay, so you would then punch that into your calculator to get your answer. So in this case, I'm getting 115 Newton. So because we have calculated the Fy, it means that we have calculated our what? Our vertical component. So our vertical component is therefore what? 115 Newton or 115 Newton. So going on to the next one. The next one is what? Is our cos, and the cos is then saying what? Cos theta is equals to the adjacent over the hypotenuse. So what do we have as the adjacent? We said that whatever side whatever side opposite to the angle is called our what? Our opposite side. And then from there it means that the other side will therefore be the adjacent, and this will be the hypotenuse. Okay, so the next one we said it's cos theta, so it will be cos theta is equals to, we have dealt with the opposite using sine, so now we are going to be dealing with what? With the adjacent. So our adjacent is represented by what? By Fx. So cos theta is equals to Fx divided by the hypotenuse, and we said we are going to call our hypotenuse what? The Fa. So we'll then substitute the Fa. So from there we know that we are given an angle of what? Of 30 degrees. So what are we going to do? It is then going to be cos of 30 degrees is equals to, what is the Fx? The Fx is unknown, so it will be Fx divided by what? Divided by 230 Newton. So from there we are then able to calculate our Fx. How do we calculate? We'll then say 230 cos what? Cos 30 degrees. And for this one, I am getting 199,19 Newton. So this fx represents your horizontal component. So along the x-axis we have our horizontal component, and then along the y-axis we have our vertical component. So let's just say that maybe you also wanted to use what? Tan theta. So it's tan theta is equals to opposite over the adjacent. So it is then tan theta is equals to, what is our opposite? Our opposite is fy in terms of theta. So opposite over what? Over the adjacent, which is then our fx. Okay, so let's just say on this one, we already know the angle is what? The angle is 30 degrees. And then let's say on this one, we know our fy, so maybe we can use this one, 115, and then we need to calculate the what? We need to calculate the fx. So from there, what are you going to do? You can divide the left hand side by 1, and then from there, what are you going to do? You can cross multiply. So the 115 multiplied by 1, it will give you 115, and then fx what? Fx 10, 30 degrees. So from there, you know that you need to divide both sides by what? By 10, 30 degrees, 10, 30 degrees, so that you can get rid of the 10, 30 degrees. And on the right hand side, you'll only be left with the horizontal component, which is your fx. So this should then give you the same answer as your fx, which is then what? 199,19 Newton. Okay, so just make sure that you really revise well on this, the horizontal component, because we said the horizontal component is represented by what? By the fx, and then we said the vertical component is represented by the y-axis. Okay, so let us have a look at this question over here. It's question 2, and it starts with question 2.1. It says Sipho and Jerry are pulling a log of mass 35 kilograms. Okay, so we have Sipho and Jerry. They are doing what? They are pulling a log of mass 35 kilograms across a rough horizontal surface. Then it says Sipho is applying a force of 30 Newton to the west. So we can see that the west is to the left hand side, while Jerry applies a force of 150 Newton at an angle of 60 degrees to the horizontal. So from the diagram, we can see that it is to the right, as shown in the diagram below. Then it says the log experiences a frictional force of what? Of 5 Newton to the west. So the frictional force is not indicated here, but we are given a clue that it is in which direction? To the left hand side. Okay, learners, I will give you about 2 minutes to have a look at this question here. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. So I will repeat the WhatsApp number. If you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. Okay. So it was saying Sipho and Jerry are pulling a log of mass 35 kilograms on a rough horizontal surface. Then Sipho is applying a force of 30 Newton to the west. So the west is in which direction? To the left. While Jerry applies a force of 150 Newton at an angle at an angle of 60 degrees to the horizontal. So we can see that Jerry is applying a force to where? In which direction? To the right hand side. And then it says, as shown in the diagram below, the log experiences a frictional force of 5 Newton to the west. So frictional force is in which direction? It is going to be to the left hand side. So 2.1.2 says determine the magnitude and the direction of the net force acting on the log. So the key words here are what? The magnitude. So remember, magnitude means what? We need to determine the size. So they want to know about the size and what? And the direction of the net force which is acting on the what? On the log. So the net force is represented by what? The net force is represented by F net. But before you are able to do all these calculations, remember you are going to need what? You are at least going to need a free body diagram. So I know that it is not asked yet, but I'm saying that for you to do the calculations, for you to do the forces, you are going to need a free body diagram. So let's see which forces do we have. We have the force of what? The force of Sipho, which is in which direction? The force of Sipho to the left hand side. And then we also have our gravitation, we also have our normal force going up, and then going down we have our gravitational force. Then which forces do we have on the right hand side? On the right hand side we have the force of what? We have the force of Jerry. So the force of Jerry is going in which direction? To the right hand side. So remember, you can represent this using what? Using the components. So using the components, it will then be what? Fx, and then going up, we'll have what? We'll have Fy. But then again, we were also told what? We were also told that we have a frictional force which is going in which direction? Which is going to the left hand side. So again, we are also going to have our frictional force there going to the left hand side. So from there, to do our calculations, what are we going to focus on? We are going to only focus on the horizontal forces. So what do we have in terms of the horizontal forces? On the right hand side we have Fx, which is the force there for who? For Jerry. And then on the applied force representing Jerry. And then on the left hand side we have the applied force that is representing who? Sipho. And then we also have the frictional force on the left hand side. So whatever force that is going to the right hand side, we are going to start with that, and then we can also choose direction to say whatever force that is going to the right, we are going to take that as positive, and then whatever force that is going to the left, we are going to take that as what? As negative. So what forces do we have on the right hand side? On the right hand side we have Fx, And then we can then say Fx minus what? A combination of forces. We have the applied force for Sipho plus by the what? Plus by the frictional force. So remember, if you have two forces on one side, then you are going to be adding those two forces. So from here, what are we going to have? We need to break down the Fx. When we break it down, it becomes what? It will become F cos what? Cos theta minus what? Minus Fs plus by Fk. So what force do we have for Jerry there? We were told that Jerry is applying a force of what? 150 Newton cos what? At what angle? At a 60-degree angle. And then what force do we have for Sipho there? We were told that Sipho is applying a force of what? Of 30 Newton plus by what force do we have for friction? We have what? We have 5 Newton. So from there it will be 150 cos 60 degrees minus what? Minus your 35. So you will then punch that into your calculator, 150 cos of 60 degrees. So that is giving me 75 minus what? Minus your 35. So 75 minus 35, what do you then get? You would then get your 40 Newton. Okay, so maybe just to emphasize on the friction, they gave us what? They gave us the direction of friction, and they said that the friction is applied in which direction? West. That is why we said our friction will go in which direction? To the left hand side. So it means that in this case, we are then deciding that whatever force that is on the right will then be represented by east, and then whatever force that is on the left will then be represented by what? By west. Okay, so it means that now in this case, since we have a positive answer of 40 Newton, we are then going to say that our direction, because remember the question said you need to determine the magnitude, which is what? Which is the 40, and then it means that our direction will therefore be in what? To the right, or where? Easterly direction, or east. Okay, so it is what? It is a 4-mark question. That means that you would then be given a mark for the formula. You would be given a mark for the substitution again, and then for the final answer with the correct unit and the correct what? And the correct direction. Okay, then looking at this one, 2.1.3, it says that you need to state Newton's second law of motion in what? In words. So we have already spoken about this one, and we said that it is when a net force F net is applied to an object of mass m, it accelerates in the direction of the net force, and then the acceleration A is directly proportional to the net force and inversely proportional to the mass. Okay, then 2.1.4, it then says that you must draw a free body diagram of all the forces that are acting on the what? On the log. So remember, we did that free body diagram. We said that you are going to have your normal force going up. Downwards, you'll have your gravitational force, and then it's either you are going to draw it this way to say this is now the force applied by who? By Jerry, or on the left hand side, this is then the force applied by who? By Sipho. Or we said that you can then draw it in terms of the components, which will also help you whenever you are doing calculations. And then we said that you can have the normal force going up, the gravitational force going down, and then to the left hand side we would have the force of SIPO and the friction this side to the left, because they said west, the friction this side as well. And then in terms of the components, we said that you will then have your Fx or your what, or your Fy. So this has a total of what, a total of what, of 5 marks. So you will then be given 1 mark for the normal force, gravitational force, the force for SIPO on the left, the frictional force on the left hand side, and the force for Jerry on the right hand side. So if you use this one, it would be the force for SIPO on the left, the frictional force, gravitational force, the normal force, and for the force of who, of Jerry on the right hand side. Now 2.1.5 says calculate the acceleration of the log. So how would you calculate your acceleration? You would then use F net is equals to ma. So remember, initially we calculated the what, the F net, and we said the F net would then be what, 40 Newton, and then we were also given the what, the mass. So what was our mass? Our mass was given as what, as 35 kilograms. So we are going to use that mass there, which is 35 kilograms, to calculate the what, to calculate the acceleration. So that means that you would then have to get rid of the 35 on the right hand side. So it means you are going to divide by the same 35 on both sides. So on the right hand side you are then left with what, acceleration, and you are then able to use your calculator there to find the magnitude of the acceleration. So in this case we are getting 1,14 meters per second squared. So this one has a total of what, of 3 marks. So you would get a mark for the formula, for the substitution, and also for the final answer with the correct unit. Okay, learners, I'm going to give you 4 minutes to have a look at this one, and then we can do it together. Welcome back, grade 12 learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us continue here. So it says Raymond applies a force of what? Of 4 Newton on a box with an unknown mass. Okay, so we have a force and we can see that it is an applied force because it is given as what? As FA. And then we also know that we have what? We have an unknown mass. Then it says the box accelerates to the right with an acceleration of what? Of 2 meters per second squared over a rough horizontal plane. Okay, so rough horizontal plane, so along the x-axis. And then it says as indicated in the diagram below. So for the first one, 2.1, it says you need to define the term mass. So when we were doing Newton's first law, we spoke about this one. We said according to the examination guidelines, we are going to define mass as a measure of the inertia of what? Of a body. So for this one, as you can see, the mark allocation is then what? Is then going to be 2 or what? Or nothing. So you need to make sure that you know the definition. Then 2.2, it says you calculate the mass of the box. So remember, we were told that we have what? We have an unknown mass. So how are we going to calculate the mass of the box? We are then going to use what? F net is equals to what? Is equals to MA. And then we are then going to decide on the direction. So let us then choose to the right as positive, and then let us then choose to the left as what? As negative. So to the right we have what? Firstly, we have an applied force, so Fa minus to the left, we have what? We have your kinetic friction is equals to what? Is equals to Ma. So this formula, remember, it is according to the formula sheet, it is according to what? To Newton's what? Second law. So on the right hand side, what do we have? We have 4 Newton. And then on the left hand side, what do we have? We have 1 Newton. So from there, we were then told that the mass is unknown. So our mass will therefore be represented by what? By letter M. But then again, what were we given? We were given the direction of the acceleration, and we were also given the magnitude of the acceleration, and we were told that the magnitude of the acceleration is what? Is 2. So from there, what are we going to do? We just need to apply maths. It is then going to be 4 minus on the left hand side. So from there, we know that the mass is unknown. That is what we are asked to calculate. And then the acceleration was then given to the right as what? As 2 meters per second squared. So we were then able to substitute and get what? And get our final answer.
Look at where you have been and ask yourself, am I happy with the results? Look at where you are right now and ask yourself, am I happy with what's going on in my life? What differentiates successful people from unsuccessful people, A students from average students, is the things that we do on an everyday basis. If you want to change your results, you need to take that one thing and repeat it over a period of time until it breeds results. And that is the art of consistency, because consistency breeds success.
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence
to about that. We had a technical problem, but we are back now. So let us have a look at this one then. So we had just discussed the calculation of what? Calculation of the mass. Calculation of the mass, and then we said that because it is 3 marks, then you would then be allocated a mark for what? For the formula, a mark for the substitution, and then also a mark for the final answer. Okay, let's have a look at the next one there. It says Raymond now pulls 2 boxes over a frictionless horizontal plane. So in this case, you can see that the frictionless is even written in what? In capital letters. So we already know that in this case, it means that friction will not apply to our calculations. So it says connected with a light inextensible string to the right with a constant force of 40 Newton as indicated in the diagram below. Okay, and then so as we can see the diagram, 3 kilogram block and a 5 kilogram block, and then in the center there, or in between the 3 and the 5 kilogram block, we are given what? We are given tension, and then to the right hand side we have an applied force of 14 Newton. So the first one there is our 2.3. It says we need to state Newton's second law of motion in words. And again, remember, for definition, it's either going to be 2 marks or nothing. So we have already spoken about this one. We said it is when a net force F net is applied to an object of mass m. It accelerates in the direction of the net force, and then the acceleration A is directly proportional to the net force and inversely proportional to the mass. Okay, so that one will therefore be 2 marks or nothing. Then we have what? We have 2.4 now, which says draw a free body diagram to indicate all the forces experienced by the 3 kilogram block. Okay, so a free body diagram on the what? On the 3 kilogram block. So what are we going to do? Remember, with the free body diagram, we are going to represent it using what? Using a dot. And then remember that all arrows must touch the dot, and then that all arrows must also do what? They must also face away from what? From the dot. So going up will then have what? Will then have our normal force. And then going down, what are we going to have? We'll have the gravitational force. And then what do we see on the right hand side here of the 3 kilogram block? We also see that we have what? We have the tension. So you can represent it using capital letter T or capital letter F and capital letter T there. So we also have tension where? On the right hand side. So they just said draw a free body diagram only for what? Only for the 3 kilogram block. So again, the mark allocation is what? Is 3 marks there. So that means that you will get a mark for the normal force, get a mark for the tension, and also for the gravitational what? For the gravitational force. So let me use this one, as I'll also use it in terms of what? Of calculations. Then 2.5, calculate the acceleration experienced by the system. Okay, so what do we have there in terms of so we need to look now at what? At both blocks. So already we've drawn the free body diagram of the 3 kilogram block, and then again, for us to do the calculations, we'll also need to draw the free body diagram of the 5 kilogram block. So what force do we have going up? We have the normal force, and then going down we have the gravitational force, and then to the right, what force do we have? We have our applied force, and then to the left we can see that we have what? We have the tension force there on the left hand side, so Ft. So remember, we said that whenever we do our calculation, our focus will be on what? Our focus will be on the horizontal forces. So in terms of the 5 kilogram block, we have Fa minus what? Minus the Ft, which is your tension. And then on the right hand side, we have what? We have Ma, so it is just a copy and paste there. Then for F applied, what are we given? We were given the 14 Newton, and then we can see that the tension was not given, so we are going to write it as the unknown. Then again, for the mass, we are going to have what? For the mass, we are going to have the 5 kilogram, and then our question says that we need to calculate what? The acceleration of the system. Okay, so it means that our acceleration will be unknown. Then we need to calculate for the what? For the 3 kilogram block. And then what do we have there? We'll firstly start by saying F net is equals to MA. So again, we'll go back to the free body diagram of the 3 kilogram block. And what horizontal force do we have? We only have tension, which is Ft, and then we have the mass of the 3 kilogram block, which is 3, and the acceleration again is what? Is unknown. So from there, what is it that we are going to do? We can see that for the 3 kilogram block, there's nothing more that we can do in terms of this equation. So you can then decide, maybe we'll then call this one equation 1. And then with the 5 kilogram block, we further need to solve so that we have what? So that we have the tension as the subject of the what? Of the formula. So how do we then make tension the subject of the formula? We will then have a negative Ft is equals to 5A plus by what? Plus by 14. So from there we can see that we have a negative tension. So it will be difficult to do the calculations if ever we have a negative tension. So we then need to decide and make it what? And make it a positive. So on the left hand side, we said negative Ft is equals to what? Is equals to 5A. So we'll then say Ft, so we divide both sides by what? By negative 1. So it will then give us a 5A. So it will then give us negative 5A minus what? Minus your 14. So from there we can see that we have made Ft the subject of the formula, that is in terms of the 5 kilogram block, and then we also have a Ft as the subject of the formula in terms of the 3 kilogram block. So from there, how do we then calculate the acceleration? Okay, so just going back to this one, so we said 5A minus what? Sorry. So when we took the 14 to the other side, it was supposed to give us what? Negative 14. And then we had a negative here of the tension. Dividing both sides by the negative meant that we'll have a negative 5A and a positive what? 14. So just to change it around, we can then say tension is therefore 14 minus what? Minus our 5A. Okay, so from there we can then use what? A simultaneous equation. But for the 3 kilogram block, we said it's going to be equation 1, and then the 5 kilogram block, we can then have your equation 2. So from there you can then say 1 into 2, or substitute equation 2 into 1. So what are you going to do? On the right hand side, in terms of the 3 kilogram block, we have 3A, and then on the right hand side, in terms of the 5 kilogram block, we have your 14 minus what? Minus FA. So from there, what are you going to do? Like terms together, so therefore 3A plus by 5A is equals to what? Is equals to 14. So you are just taking this 5A to the other side. So it will be 3A that was already there plus by the 5A. And then on the right hand side, what are you left with? You are left with the 14. So from there it is 3A plus by 5A, which is equals to what? 8A, which is then equals to 14. So from there you are then able to calculate your acceleration. What is it that you are going to do? You are then going to divide both sides by what? By 8. And why are you going to do that? So that you can get rid of the 8 on the left hand side, and that you are only left with what? With the acceleration as the subject of the what, of the formula. So from there it is then acceleration is equals to the 14 divided by what? Divided by 8, which is then 1,75 meters per second squared. Okay, so they just said calculate the acceleration experienced by the system, but we know that acceleration is a vector. That means that it will have a magnitude. Magnitude is what? It is the size, and it will also have what? The direction. So in this case, the 1,75 is the magnitude, but because then we then have a positive answer, our direction will be where? It will be to the right hand side there. Okay, so just to recap quickly, we said that whenever we calculate this, you firstly need to draw your what? Your free body diagram. For question 2.4, we were asked to calculate the free body diagram, and as indicated here, we drew the free body diagram, and then from there, because we did not know all the forces that were there just by looking at the diagram, we then had to draw the free body diagram in terms of what? Of the 5 kilogram block. And then from there we said we are only going to focus on what? On the horizontal forces. And then we said in terms of the 3 kilogram block, our horizontal force, we only have one, which is what? Which is our tension. But in terms of the 5 kilogram block, our horizontal force is what? Is tension and the applied force. And then we said that, okay, for whatever force that is going to go to the right, we are going to take the direction as what? As positive. And then for whatever force that is going where? To the left, we are going to take that direction as what? As negative. So from there, in terms of the 5 kilogram block, we said it is going to be the force applied minus the tension, and then we therefore calculated so that we can have what? We can make Ft the subject of the formula. For the 3 kilogram block, we only had the tension, so it was easy to make the tension the subject of the formula. From there, what did we do? We said we can then substitute equation 1 into equation 2, or 2 into 1, and then do what? And then from there, we said we are going to find the like terms. So the like terms in this case, we said it's going to be our 3a plus by our 5a, and then we equate that to what? To 14. We therefore calculated the acceleration, and then we gave it what? We gave it direction. So in terms of the mark allocation, you would get a mark for F net is equals to MA, and then you would get a mark again for the substitution, and then another mark for the substitution, and then another mark for simultaneous equation there, and then another mark for the final answer with the correct unit, and also the correct what? And also the correct direction. Okay, so that is a total of what? A total of 5 marks. Okay, learners, for this one, I will give you 3 minutes. And also the what? The acceleration. And then now the first question now asks, write a suitable hypothesis for this experiment, and that is for 2 marks. So a hypothesis would be, what do you think is going to happen in terms of this experiment? So we can see that we have what? We have the force on the y-axis, and we also have the acceleration where? On the x-axis, and then we can also see that we have what? We have a straight line. So whenever we have a straight line, then it means that there must be a relationship which is what? Which is directly proportional. So in this case, we can then answer that question by saying that what? The F net is directly proportional to what? Is directly proportional to the acceleration. So what does that mean? It means that as the net force, so this net force, as it increases, the acceleration will also do what? Will also increase. Okay, so that would be our answer for the first one, to say that as the net force increases, the acceleration will increase. Or we can also say what? We can also say that F net is directly proportional to the what? To the acceleration. Now 4.1.2 says you must indicate the variable that must be kept constant during this what? During this experiment. So what is it that you are going to keep constant? What is it that is not going to change as you perform the experiment? So according to Newton's second law, we only have the three variables there. We have the net force, which is already there on the graph. We also have what? We also have the acceleration. So it means that we then have our independent variable and our dependent variable, but the only one which is then not there is then going to be our what? It is then going to be our mass in what? Our mass in what? In kilograms. So that is the variable that we are going to keep constant. That is the variable that is not going to change as we perform the experiment. Now 4.1.3 says you need to calculate the gradient of what? The gradient of the graph. So how do we calculate the gradient of the graph? Remember that the gradient of the graph, we are then going to say change in y divided by change in x. So just to go back to the graph, the gradient of the graph is change in y divided by what? By change in x. And then change in y will be what? Will be y2 minus y1 and x2 minus what? Minus x1. So it means that from this graph, you need to be able to choose what? To choose 2 points that you are going to work with. And those 2 points will represent your x1, y1, and your y2 and what? And x2. So maybe let's just say that we choose what? Maybe let's say we choose 0 and we choose another point, maybe the last point there on the graph. It means that you must already know or have a knowledge of how to what? Have a knowledge of how to interpret the graphs. So what is the first thing that you are going to do? On the x-axis and also on the y-axis, you can see that the first one there is represented by what? By 0.2. And then on the y-axis again, we also have what? 0.2. So that means that you then need to calculate the number of blocks that you have from 0 to what? To 0.2. And then how many blocks do you then have? You can see that you have how many? You have 10 blocks. So what are you going to do with the 10 blocks? We're then going to say 0.2 divided by 10 blocks. What does it give you? So 0.2 divided by 10 blocks. What does it give you? It gives you 0.02. So what does that mean? It means that each and every block that you see is represented by what? By 0.02. So it means this one is 0.02, this one 0.02, and also this one is also 0.02. So each and every block is represented by what? By 0.02. So remember, we are looking for what? The 0 at the bottom here will represent our x1 and our y1. And then the last point will represent our x2 and our y2. So right now we are looking for the x-axis, and then we are then going to say, okay, on the x-axis we can see that the last point there is represented with just after the 0,6. And then remember, we agreed that each and every block is represented by what? By 0,02. So it means that you are then going to say, okay, how many blocks do you then have after the 0,06 so that you can get to what? To that certain point that you are looking for. So you have 2 blocks, so you are then going to say 0,02 multiplied by the 2 blocks. What does it give you? It gives you 0,04. So remember, you are still looking for what? You are still looking for the x-axis. So to count from 0 to the point you are looking for, you are then going to say 0,6 divided by what? 0,6 plus by 0,04 will then give you your what? The value for the x-axis. Okay, so it would be 0,04 plus by 0,6, which then gives you 0,64. So it means that for the value, your x2 is then represented by 0,64. So the same for the y-axis. The first point there is represented by what? Is represented by 0,2 and then 0,4 going up. So with the 0,4, what are you going to do? You will then count the number of blocks that you have in terms of the y-axis, and then you will see that you have how many blocks in between. You have 10 blocks. So what are you going to do? Again, it would be 0,2 divided by the number of blocks that you have, which will then give you the very same what? 0,02. So after you have then calculated, it means that each and every block that you see is represented by what? Is represented by 0,02. So from there you are looking for what? You are looking for the exact value in terms of the y-axis. And then how do you get to that exact value? It means that you then need to count from the closest one, which is 0,8, how many blocks you have there. So it is then 2, 3, 4, 5, about 6 blocks that you have going up. So if you have 6 blocks going up and each block is represented by what? By 0,02, what will your y value be? So it means that you are then going to say 0,02 multiplied by 0,02 multiplied by the 6 blocks. It gives you what? It gives you 0,06. So I said 0,02 multiplied by the 6 blocks. It gives you 0,06. So what are you going to do with that 0,06? From the closest, which is your 0,8, you are then going to add your what? Your 0,06 so that you can have your y value. So you would then say 0,06 plus by 0,8, which then gives you your y2 value of 0,86. So just make sure that you practice the analysis of the what? Of the graphs. So in terms of y2, we have what? We have 0,86, and then in terms of y1, we made it easy to be 0 so that we don't have to be doing a lot of calculations. So our y1 value will be represented by 0, and then in terms of the x2, we are then going to have what? 0,64, and then our x value will therefore be represented by what? By the 0. So from there, what do you have? You then have 0,86 divided by what? Divided by 0,64. So your gradient will therefore be represented by the 1,34. Okay, so 1,34 for the gradient. So it means that it was what? It was 3 marks. So it means that we are going to allocate 1 mark for the formula. So let's give 1 mark for the formula here for the substitution, and then another mark for the final answer there. Okay, 4.1.4, use the graph to determine the magnitude of the force that must be applied to achieve an acceleration of 0.3 meters per second squared. So we are looking for what? We are looking for the magnitude of the force. And then for the magnitude of the force, what is it that we are going to do? So it said given an acceleration of what? Of 0.3. So it means that you would then have to find out where your acceleration is there. So if it's going to be 0.3, it means that it's going to be in between what? It's going to be in between the 0.2 and the 0.4. Or if you want, you already know that each block is represented by what? Each block is represented by 0.2. So you can then calculate there. You can then calculate to say, okay, how do I then get to 0.3 from what? From 0.2. So you then have an option of what? You then have an option of saying 0.2 plus by what? Plus by 0.02, because you know that each block is represented by what? By 0.02, and then again you add another 0.02 and another one and another one, so it would be about 5 blocks. About 5 blocks. So 5 blocks, it means that it is going to be in the center. So it's 1, 2, 3, 4, about 5 blocks, which is somewhere there in the center. So from there, you would then go up on the graph and determine the what? And determine the net force. So again, we said each block is represented by what? By 0.02. So from there, how many blocks do we have after the 0.4? We can see that to get to this point, we have 2 blocks. So it means that you are then going to say what is your 0.02 multiplied by 2? So we can see that we are getting 0.04. So you want to find a way then to add this 0.4 to the number of blocks that you have. So we said it's going to be 0.4 plus by the number of blocks. We said it's 2 blocks. So therefore, that will then give you your 0.44 what? Newton as your force. Okay, so this one was just 1 mark, so it means that you just needed to draw what? You just needed to find where your 0.3 was, and then use the graph to find the what? To find the magnitude of whatever force that you are given. Okay, learners, so for today we have ran out of time, so I am going to give you some homework. You can have a look at this one, so you can then quickly take a screenshot of this homework that I'm giving you on the multiple choice question. Then you can also take a screenshot of this one as well. That is a multiple choice question. And we are going to end the lesson here for today. And I'm going to end with these words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." Thank you so much, learners. I'll see you next time and same place. Thank you. Bye.